The curve C, shown in figure 1, has polar equation r equals 4 plus cos 2 theta. At the point A on C, the value of r is 9 over 2, so this point here. The point N lies on the initial line and AN is perpendicular to the initial line. The finite region R, shown shaded in figure 1, is bounded by the curve C, the initial line, and the line AN. Find the exact area of the shaded region R, giving your answer in the form P pi plus Q root 3, where P and Q are rational numbers to be found. So first what we want to do is we want to determine the point A. So at the point A, the value of r is 9 over 2, so we can substitute r in this equation for 9 over 2, and then we can subtract 4 on both sides, which gives us cos 2 theta equals half, and then we can just do the inverse of this, and that gives us 2 theta equals pi over 3, and then we divide by 2 to find theta on its own, which is pi over 6. So now we know that our coordinates for A are 9 over 4, which is r, and theta is pi over 6. Now we need to find the exact area of this sector, which is given by this equation, the integral of half r squared. So the sector area is given by this, and we have our upper and lower bounds, which is pi over 6 and 0. And we've just put this r into the equation, and obviously as it's r squared, we've squared this. And then we're going to take the half out of the integral, and we will expand the r squared, which gives us that. And using our knowledge of identities, we know that cos squared 2 theta equals 1 plus cos 4 theta over 2. So we can just put that back into this equation. And now we have 16 plus 8 cos 2 theta plus half cos 4 theta. And obviously we can rearrange this, so this will give like 33 over 2. And then now we need to integrate it. I'll probably just skip this step, and this is what you're left with. 33 over 2 theta plus 4 sine 2 theta plus 1 over 8 sine 4 theta. And you've still got the half on the outside. And then we're going to substitute this pi over 6 into the theta. And then we've done that here. And if we expand that out, this is what we're left with, and we can just keep expanding, and we're eventually left with this equation. And this gives us the area of the sector OAC. And now we need to work out the area of AON, which is this triangle, and to do that we need to find the base and the height. So the base would be this, which is Rx, and as we know, x equals r cos theta, and we know that our r is 9 over 4, and our theta is pi over 6. We can put that back into this equation, and that gives us 9 root 3 over 4. So this is our base, and then to work out the height, we just do y equals r sine theta, as this is our y. We can put those values back into the equation, and we're left with 9 over 4. So our height is 9 over 4. And then we can put these values back into this equation to find out the area. And that gives us 81 root 3 over 32. Now to work out area R on its own, we need to do this sector minus the triangle. So we've got our sector area here and our triangle area here. Oh, don't know what just happened. So we do that, and it leaves us with 11 over 8 pi minus 48 root 3 over 32. Which can be simplified into 11 over 8 pi minus 3 over 2 root 3. And our P is 11 over 8 and our Q is minus 3 over 2. Figure 2 shows the two curves given by the polar equations. R equals root 3 sine theta, R equals 1 plus cos theta. Verify that the curves intersect at the point P with the polar coordinates 3 over 2 and pi over 3. So I'm guessing this is point P. So the first thing that we need to do is we know that our r from this is 3 over 2, and we're going to put this theta value back into each of these equations to verify that the r will equal 3 over 2. So this is our first equation, and that is our second equation. I'm going to start off with our first equation. which is r equals root 3 sine pi over 3, because we're putting this pi over 3 into the theta, and that will give us r equals 3 over 2, which matches, and then we can do the same for 2. That should be a 2, sorry. Yeah, so it's r equals 1 plus cos, and then the theta will be pi over 3, and that again gives us r equals 3 over 2, which matches that. Use calculus to find the exact area of r, giving your answer in the form a bracket pi minus root 3, where a is a constant to be found. So we need to find out the area of this now. And to do so, we're going to work out the area of the circle and then the area of this. Okay, so the area of the circle is equal to the area of r equals root 3 sine theta, which is this given here. And first what we're going to do is we obviously know our equation, which is half r squared. And then we know that our limit is pi over 3 and 0. And then we just put these back into the equation. And then we're going to expand this equation so it looks like this. And then using our knowledge of identities, sine squared theta equals 1 minus cos 2 theta over 2. So we're going to put that back into this equation, which will give us this. And then we've just taken the 3 over 4 on the outside. Obviously, you can work out what this is separately. You can pause the video, whatever. But yeah, I'm just skipping steps because it's quicker. And yeah, this will equal, once you differentiate it, 3 over 4 brackets theta minus half sine 2 theta, and then we put this value back into the theta, and we can minus it from this minus 0 into these values, but obviously you can just do pi over 3 to make it simpler. And that will give us this, and then we can just expand that, and that will give us pi over 4 minus 3 root 3 over 16, and that is our value for the area of the circle. And now we need to work out the area under the cardioid, which is this, and that will obviously be the area of 1 plus cos theta. And then we use the same equation, half r squared, and we put these limits in, and we just expand that, and it gives us this. And then we use the identity, cos squared theta equals 1 plus cos 2 theta over 2, and we put that back into the equation. Okay, and then we integrate it, and we get this. And then we get a2 equals half bracket 3 pi over 2 plus 0 as sine pi is just 0, so this cancels out and this cancels out. And then minus pi over 3 in the values of theta, and that gives us that. And that is our second area. And then of course now all we need to do is just add these areas. I think I might have said we minus the areas before, but I meant to say that we add the areas, and that is that. And then we will get 3 over 4 bracket pi minus root 3, and as we can see, a will equal 3 over 4.